These are the problems for lesson 8. Okay, in lesson 8, we have learned that the area of a rectangle is length times width. Okay, I'm trying to get my pen up here working. It's not cooperating with me, and I'm not sure why. Here we go. Okay, we want a pen. Made that mark. Takes a little while, I guess, to pick up the signal. We have an L-shaped figure here, and it's not possible for us to find the area of an L-shaped figure, so we have to break it up into two rectangles. So here we've made a dotted line down here, and we have rectangle A, goes all the way around like that, and stops here. And then this part is called rectangle B. So the area of this shape is the area of A plus the area of B. Okay, well, we know that area equals length times width. So we're going to have LW for A, and we're going to add it to LW, L times W for B. This width is 5, and this length is 2, and the length is 5 for area A. So 5 times 2. We'll substitute in 5 for the length and 2 for the width. Plus, in this whole length is 6, but the part that's the length of B just goes from here to here, so that would be 4, and the height is 2. Okay, or the width is 2. Length 4, width 2. This is 10, this is 8, and our total area is 18 centimeters squared. Okay, in this, we've divided up a different way to get rectangle C and rectangle D. So these two areas are made up of the area of C and the area of D. We're going to add those two areas together. They're both rectangles. So we're going to do A equals L times W again. A equals L times W. In rectangle C, we have a 2 width and a 3 for a length. So 2 times 3. In this, we have 6 times 2. The length is 6 and the width is 2. So we have 6 plus 12 equals, again, 18 centimeters squared. So no matter how you divide that up, it is going to be 18 centimeters squared. This one is a little bit different. It says find the area of the shaded portion of this figure. All angles are right angles. Dimensions are in meters. Well, we want to know, this is the shaded portion, all this in here, the blue. Okay, that's the shaded portion. We don't want this. It would be like if you had a giant surround and you had a rectangular swimming pool. You're not going to count that for pouring cement. You're going to take it away. So when we have a shape like this, we know that the area is going to be one big rectangle minus the area of the smaller rectangle. Whenever you find shaded area, it's a subtraction usually. Okay, we know that each area is equal to the length of the rectangle times the width of the rectangle. We do our largest shape first. 10 times 8 is 80. Minus 6 times 2, minus 12. And 80 minus 12 would be 68 square meters, and that would be your answer. Okay. Okay, we want to find the areas of these rectangles. This is a right triangle. We know because it has the right triangle mark in the corner. So whenever you see the right triangle mark, a little box, One of them is the length or the base, and one is the height or the width. Okay? We know that area equals base times height divided by 2. Our base is 4, our height is 3. So our area is 6 oops, that doesn't look very much like a 6 inches squared. Now this is an acute triangle. In an acute triangle, the height is drawn inside the triangle. This is the height. Okay? And again, we have the same base and height. We use the same formula because it's the triangle. So 4 times 3 divided by 2, and the area is 6 inches squared. 12 divided by 2. This is an obtuse angle. This right here is a big obtuse angle. When we have an obtuse triangle that's in this, its base is like this, and the obtuse triangle is on the base. One base is making up one side of it. We draw height outside, so this is the height for this triangle. It's also 3. And we do area equals base times height divided by 2, and it equals 4 times 3 again divided by 2, which is 12 divided by 2, and that equals 6 inches squared. Okay, this is trying to fool us. It's a right triangle. We can see that because of the little box here. So we're going to ignore the 10 because we know the base and the height are always connected to that little box in a right triangle. So base times height divided by 2, writing it over and over is how you learn it. 6 times 8 equals 48 divided by 2, and that equals 24 feet squared for this triangle. So don't be fooled if you see it set up this way. In a right triangle, always the base and the height are connected to the little box that shows you that it's a right triangle. We have another what we call composite figure. Find the area of this figure. Corners that look square are square, and dimensions are in yards. Well, this time we have a figure made up of a rectangle and a triangle. And the triangle is a right triangle. It tells us that corners that look square are square. We know this is length times width, and we know this formula is base times height divided by 2. Well, the length and the width of the rectangle are easy. 6 times 4. We have a base of the triangle, but we don't have the height. However, we know that opposite sides in a right triangle are equal. So this height has to be equal to 4. Okay, that height has to be equal to 4. So we have 4 times 4 divided by 2. 6 times 4 is 24. 4 times 4 is 16 divided by 2. So we have 24 plus 8, and that equals 32 square yards. And that's our answer. Okay, next problem. In a circle, in a circle, we know that the area of a circle is pi times radius squared. The radius of this circle, a radius, remember, is a line drawn from the center right out to the edge of the circle, to a point on the circle. That's the radius. Okay, pi times 3 to the second power equals 9 pi centimeters squared. You can leave it like that, or you can multiply it out and approximate the answer using your calculators. Okay, this is not going away for some reason, and I'm not sure why. I'll use my mouse to try and get it to go away, and it's not going away. Okay, there it goes. All right. Now, the area of the circle is 25 square meters. Find the radius of the circle. this is one that you have to divide, okay? We know what the area is. It's 25 square meters. That's given to us, okay? So we'll write our formula down. A equals pi r to the second. We do 25 equals pi times r to the second. Now, pi is simply a number close to 3.14. So we're just going to divide pi by that. Divide pi into 25. And while you're doing that, you're going to get a big, long decimal number, because pi is an irrational number. Okay, I'm looking for my calculator now to do this, so I get the same answer that you do. And I'm going to divide 25 divided by second. Remember where the pi key is, right over the caret key. Enter. And I get 7.9577. We want to round to approximately 3 decimal places. That's what Mrs. Toole likes us to do. So 7.957, and I look at the 7 next to this 7, and it's a 7, so I'm going to make it an 8. Now, on your calculator, you also have something called a square root key. If you look down your first column on your calculator, you'll see x squared. It's about halfway down, and you'll see above it a little symbol that looks like this. Okay? We want to take the square root of 7.958. That's what we want the square root of. You hit your second function button, the yellow button at the top of the first column of keys, and you put in your, that gets your square root up, and you put in 7.958 and enter. And now we get another big long decimal number, but it is approximately 2.821, and that's the length of the radius. You have to take the square root of both sides of that equation. Okay? Now this is another composite figure, and this is made up of a triangle, the yellow part, a rectangle, the purple part, and a semicircle. Now remember, when we do the area of a semicircle, we have to divide the area of the whole circle by 2. Okay, so we've got the triangle, and I always recommend drawing the shapes of what you're adding. Okay, I always recommend putting the formulas underneath as well. That helps you to learn them. And then pi r squared divided by 2. Well, the triangle has no measurements at all. This is the radius of the semicircle. It's 2 inches long. I know therefore that from this point to here is 2, and from this point to here is also 2. So 2 plus 2 is 4, and opposite sides have to be equal in a rectangle, so that side must be 4. Now I have a whole length here equal to 7. Okay, that whole length is equal to 7, and the top of it is 5. 7 minus 5 then gives us 2 for this base of the triangle. So I'm going to multiply 4 times 2 and divide by 2. For the rectangle, I'm going to multiply 5. This is the base of the rectangle right along here, times the height that we found, or the width that we found, 4. And then for the circle, that's the easiest one of all. Pi times 2 to the second divided by 2. 4 times 2 divided by 2 is 4. 5 times 4 is 20. And this would be 4 pi over 2. I can reduce that, and so I have 24 plus 2 pi, and that's going to go in parentheses, inches squared. You can leave your answer like that, or you can approximate it by multiplying 2 times pi and then adding what you get to 24. Okay, this is a parallelogram. The area of a parallelogram is base times height. Now remember, a height is always straight up and down. So whenever you see a parallelogram and you see the arrow going up and down with the 4, you know that's a height. And you're going to put that number in right under the h in the formula. This is the base. 8 times 4 is 32, and this is 32 centimeters squared. Okay. This is a trapezoid. Now, again, whenever you have a trapezoid, it's really made up of 2 triangles, your book says. Okay, that you can do this as 2 triangles. This triangle has a base of 9 and a height of 4. The height of the triangle is never, or a trapezoid is never the slanted line. Okay, the base of this triangle within the trapezoid is 15, and its height is 4. So we're going to break that up into 2 triangles, and we're going to add those 2 areas together. Remember, I always recommend writing down your formula. The base of this would be the 9, and the height is 4. The base of this is 15, and the height is 4. This is 36 divided by 2, that would be 18. This is 60 divided by 2, that would be 30. And this would be then 48 meters squared is the area of the trapezoid. And that's the last problem. Now there is another way to find the area of a trapezoid. This is the formula. 1/2 the height times the sum of those 2 bases. It gives you the same thing, but it gives it all in one step. So 1/2 times 4, 4 remember is our height, times 9 plus 15. 1/2 times 4, we always do work in parentheses first, so I better do that first. And this would be 24. 1/2 times 4 is 2, and 1 times 2 times 24 is 48 meters squared. And that concludes the problems from Lesson 8.